Welcome back, everyone. I hope all of you are keeping healthy and safe. I have another interesting problem today, so let's say what the problem statement says. The question says, how can you represent days of a month using two six-sided dice? Six-sided dice. You have two dice and both of them are six-sided. We all know a dice is six-sided, right? Now the constraint of the problem is you can write one number on each face of the dice from 0 to 9, and you have to represent days from 1 to 31. Now what do I mean to say? For example, if you have to show 1, now the way to show number 1 on both the dice is one dice should show 0 and another dice should show 1. Alright. Now similarly, if you have to show a number 29, so one dice should show 2 and another dice should show 9. So that is what the problem means. So basically, you have to number each side of the dice in such a way using 0 to 9 such that all the days of a month can be represented. So I hope all of you might have got the problem statement very well. So now you all can pause the video, think of the answer, and let's see who gets it correct. So let's come to the solution of the problem. The solution says you must number the six faces of the first dice as 0, 1, 2, 3, 5, 7, and you must number the six faces of the second dice as 0, 1, 2, 4, 6, and 8. Now, if anyone of you got the right answer, a very big congratulations. Yippee, you did it. Now, let's see how did we actually get this answer. Let's find out. Now, just imagine the fact that you have to represent numbers 11 and 22, right? Because in a month you have these numbers present as dates like 11th Jan or 22nd February, right? Now, since you have to represent the numbers 11 and 22, so this imply that number 1 should be there in both the dice as well as number 2 should be there in both the dice. And this is very much evident from the solution. Both die must contain number 1 as well as number 2, because only in that case it is possible to represent 11 and 22, right? Now think another fact. We also have to represent dates which are of single digit. For example, first, second, third, up till ninth. And to represent these dates using two dice format. For example, there is number 2. So using the two dice, you will represent it as 02. 9 will be represented as 09, right? Because you have to represent them using two dice. So one dice will show 0 and another dice will show the actual number. Alright. Now, since in a dice there are six faces, so let's say these are the six faces 1, 2, 3, 4, 5, 6 of dice 1, and these are the six faces 1, 2, 3, 4, 5, 6 of dice 2. Alright. Now we have already fit 1 and 2 on these positions. Alright. So we have 4 vacant spots 1, 2, 3, and 4. 4 vacant spots in dice 1 as well as dice 2. Now we have to represent some single digit dates. For example, 01, 02, 03, 04, and so on up till 09. So let's put a 0 on the first vacant place of dice 1, right? Now using this 0, we can represent the date 01 because 0 is present on dice 1 face and 1 is present on dice 2 face. We can also represent 02 because 0 is present in dice 1 and 2 is present on dice 2. Now to represent 03, 0 is already present on dice 1, so let's put a 3 here, right? To present 04, 0 is already present on face 1 of dice 1. So let's put a 4 here, and similarly 0, 5 here. Now since we have filled these many combinations, so it is possible to represent the single digit dates ranging from 01 till 05. Yes, all of them can be represented using this format. But we also have to represent the single digit dates like 06, 07, 08 and 09, right? Now for this, now you see 0 is present in dice 1, but now 6, 7, 8 and 9, 4 numbers are left. So it's not possible that all 4 numbers can be fitted in just one vacant place of dice 2, right? So what we do, we place a 0 in dice 2 as well, and we put the remaining numbers, that is 6, 7 and 8 on the vacant places of dice 1, 6, 7 and 8. Because it is not possible that only one dice contains 0 and the other dice contain all the remaining actual numbers from 1 to 9. This is because one dice has only 6 faces, and since we have already filled 1 and 2 on 2 faces, so only 3 distinct combinations are possible on the vacant spots of any one dice. Alright, to represent the remaining numbers, we have to include a 0 in the last or any one vacant place of another dice as well, and we have to represent the remaining numbers on the first dice. So what do we actually come to know by this concept? We come to know that 1 and 2 have to be present on both faces of both the dice, right? As well as 0 has to be present on both the dice, dice 1 as well as dice 2. In short, 3 numbers 0, 1 and 2. These 3 numbers have to be present in both the dice. This is the heart of the problem. Without representing these 3 numbers on any one dice, we will not be able to represent all the 31 days of the month. Alright? Now many of you might be wondering that 4 numbers were left, 4 6-digit numbers were left, 6, 7, 8 and 9. We have filled 6, 7 and 8, but what about 9? So let me introduce a twist in the story. We are going to use the technique of rotation here. Now what do I mean by rotation? Let's take the number 6 for example. When you rotate the number 6, it becomes 9. That is, if this is the number 6, then viewing 6 from this side, it appears as 9, and when you view 6 from this side, it appears as 6. So 6 can be treated as a magic number because when we rotate 6, it switches to 9. That is, its value changes. So in this way, using the concept of rotation, the number 9 is also covered, and all the single digit dates will be able to represent them correctly. All right. So guys, we can view the solution in a better notation like this. That is, all the 6 faces of dice 1 will be numbered as 0, 1, 2, 3, 5, 7, and all the 6 faces of dice 2 will be numbered as 0, 1, 2, 4, 6 and 8. And this number 6, on rotating this number, it will change to 9. So we will be able to represent all the 31 days of the month from 1 to 31 using this combination. Alright. Now note one thing. A dice has 6 faces, right? Now 0, 1, 2 have to be present in both the dice, right? Now it's up to you to fill the remaining numbers in any fashion you want, right? There is no restriction. For example, you can put a 3 here, you can put a 4 here, 5 here, 6 here, 7 here, or 8 here, right? Or even any other combination is possible, like 3, 4, 5 here, 6, 7, 8 here. It's totally up to you. The only crux is that 0, 1 and 2, they have to be present in both the dice, and rest is all up to your convenience, right? So A few possible solutions are that dice 1 and dice 2 be numbered as 0, 1, 2 because they have to be present everywhere 0, 1, 2. So 3, 4, 5. So this is dice 1 representation, and dice 2 will be 0, 1, 2, 6, 7, 8. So using this combination, we can represent all the 31 days of the month. Another possible representation is if this is dice 1 and this is dice 2. 0, 1, 2, 0, 1, 2, right? Now 3, 4, 5, 6, 7, 8. So this representation is also possible, right? So similarly, any combination can be answered, any combination. Just we need to take care that 0, 1, 2 must be present there on both the dices. Alright, this was the actual crux of the problem. The remaining spots you can fill as per your convenience. There is no restriction. We'll be able to represent all the 31 days of the month using this notation. Alright. So guys, that was all for this problem. I hope you must have enjoyed the concept and you must have learned something. So please like the video, share it if you find it of utility, subscribe to my channel, share it with your friends as well, and stay connected for further videos. Thank you very much.